So in the last video, you found an estimate to the area under the graph of a function using lower estimates and upper estimates. In other words, over each interval, you either pick out the lowest point on that interval and let that define the height of the rectangle, or you pick the highest point on the interval and let that highest point define how tall that rectangle is. And that would give you an underestimate and an overestimate to the actual area under the graph. Here we're going to, instead of doing an underestimate or overestimate, we're going to use this idea of using the midpoint to determine the height of each rectangle. Alright, so we're going to estimate the area under the graph of f of x equals 2 over x squared between x equals 2 and x equals 4. We're going to use 4 rectangles, and we're going to use the midpoint of the base of each rectangle to find its height. So let's see what this looks like. It helps to have a basic idea of what the function does in general. So let me just show you kind of a big picture idea. 2 over x squared, just a rough sketch. That graph is going to be doing something like this and this. All right, but we don't really, it helps to have kind of a mental picture of what's going on with the function whenever you kind of zoom in, but we're really interested in zooming in on what's happening between 2 and 4, because that's the interval that they gave us. They gave us the interval from 2 to 4. We want the area under the graph between 2 and 4, so that would be this region here, and we're trying to come up with an estimate to this area under the graph. So to do that, again, we don't know yet how to find the exact area. We'll get there soon, but we're going to come up with an estimate. All right, so let's zoom in on this region of the graph that we actually care about, and we don't really need the rest of the graph for this. We just need to know what it looks like between 2 and 4. All right, so let's look at this graph here. We'll go 1, 2, 3, 4. And the graph does something like this over this interval. It's decreasing over this interval, but it's not decreasing in a straight line. Again, if you go to that zoomed out version of it, you can see it has kind of a curve to it. Now, we're looking at this function between 2 and 4. And the first thing we need to look at is how many rectangles we need. We're going to estimate the area using 4 rectangles. So we need to think about how we're going to get 4 rectangles out of this interval. This interval from 2 to 4 is where we're focusing. Well, obviously, if I'm going to need 4 rectangles to get 4 little subsections, it's going to look something like this, where our first rectangle is going to go between 2 and 2.5. The second rectangle is going to be between 2.5 and 3, and then between 3 and 3.5. And then our fourth rectangle will go between 3.5 and 4. All right, so we've got 4 sub-intervals here, and over each sub-interval we need to draw a rectangle. And we were told specifically how to find the height of these rectangles. All right, so we were told to find the height using the midpoint of each of these intervals. Okay, so just to kind of give you a picture of what's going on, my first rectangle is going between 2 and 2.5, and so I've got this rectangle coming up here to the graph, but how tall do I want to make this rectangle? In the previous video, you looked at, okay, I could use the low point on this interval and use that to determine the height of my rectangle. That would give me an underestimate. I could use the high point on this interval. Using this high point, I could make my rectangle that tall, and then that would give me an overestimate to the area. We're not doing either of those. We're picking the midpoint. So right in between 2 and 2.5, that would be at 2.25. We're going to go up to the graph from this midpoint and that is going to be the height of our rectangle. So this very first rectangle looks something like this. All right, on our next interval between 2.5 and 3, again, you can imagine we've got this rectangle that we're forming here, but we need to know how tall to make it. But again, we're using the midpoint of this little subinterval. So what's halfway between 2.5 and 3? Well, 2.75. All right, so what happens when I plug 2.75 into my function? I get this point here, and that is the height of this second rectangle. All right, so then you can continue it in this way. It's pretty straightforward, I think, from here. The next interval between 3 and 3.5. Again, we start working on finding this rectangle, but we need to decide how high it is. And we're using the midpoint, so that would be between 3 and 3.5 would be 3.25. From 3.25, come up to your function. Wherever it hits the function, that's the height of that rectangle over that interval. And then you do it one more time. Between 3.5 and 4, the midpoint of that last interval would be 3.75. And so this last rectangle, you use 3.75 to define the height of that rectangle. So now we have 4 rectangles, and the height of each rectangle is defined by these 4 points on the graph. The point that we got when we plugged 2.5 into our function, so this would be the point 2.5, or sorry, 2.25. And then the y value is what we get when we plug 2.25 into our function. That would be 2 over 2.25 squared. That would be this very first point. And so the y value here, this 2 over 2.25 squared, is the height of this first rectangle. And in the same way, each one of these midpoints that we found, where they hit the graph, if I plug those x values into my function, that tells me how high that rectangle is. Now, to do my areas, if I'm going to add up the 4 areas, I need to know the base times the height. Well, how wide is this first rectangle? This first rectangle goes between 2 and 2.5. How wide is that? That's a width of 1/2. The second rectangle goes between 2.5 and 3. So what's my base? My base is also 1/2. So each one of these rectangles has a base of 1/2, right? So I'm going to do 1/2 times my first height, plus 1/2 times my second height, plus 1/2 times my third height, plus 1/2 times my fourth height, and that gives me my four areas of my rectangles. Add those up, and I get my estimate. Since each one of those bases is 1/2, I can just factor this out. I'm going to write 1/2 and then times, and then add up the heights. So I've got the sum of the heights of my rectangles. And my base, I just factored it out because it's the same in all 4 rectangles. The base for each one of my rectangles was 1/2. All right, so my first height was 2 over 2.25 squared. My second rectangle is what I get when I plug 2.75 into my function, so that'd be 2 over 2.75 squared. And then my third rectangle, its height comes from what I get when I plug 3.25 into my function. So f of 3.25 would be 2 over 3.25 squared. And then my last rectangle, its height comes from plugging 3.75 into my function. So that would be 2 over 3.75 squared. All right, and once you get here, it's basically a calculator exercise. Punch this into a calculator and see what you get. In your homework, it'll tell you if rounding is necessary. It'll tell you how many decimal places to round to. Let's round this to 4 decimal places in this one. So what this comes out to is roughly 0.4955. You can punch this into a calculator and double check this yourself. But 0.4955 is my estimate to the actual area under this graph between 2 and 4. I estimated this using 4 rectangles and the midpoint of those 4 rectangles to find the height of those rectangles. All right. And again, when I add up these areas, just to make sure this was clear, I'm doing base times height 4 times, right? I'm doing 1/2 times the first height, plus 1/2 times the second height, plus 1/2 times the third height, plus 1/2 times the fourth height. So I'm doing base times height 4 times, but I just factored the base out because it was the same for all 4 rectangles. All right, so hopefully that will help you with your homework questions. Again, the basic idea on all of these is that we're just adding up areas of rectangles. The only trick to it is figuring out the height of the rectangle. In this case, we use the midpoint, but in some other homework questions, you'll use the high point or low point over each interval to determine the height in those cases. All right, so now you should be all set for your homework, and in the next section, we'll get a little bit closer to seeing how all of this ties into the calculus, the derivative stuff.